Okay, this video is going to add to some of the things that we've already been learning about the concept of intelligence quotient and the development of tests that could measure an individual's intelligence versus that of the general population. Again, some of this is review from what you should have picked up from the textbook reading and also what was presented in the Discovering Psychology video that you watched for homework. So I'm just going to hit some highlights on some of the most important figures and their contributions to the development of a clear measure for intelligence, which we'll find out is something that has not been fully accomplished by some views of things. All right, the first key figure, of course, is Alfred Binet. He was the first person to really seek to develop a test of human intelligence. His biggest contributions were these concepts of mental age and chronological age. Chronological age is simple enough. It's how old you are chronologically speaking. So obviously 1-year-olds, 2-year-olds, 3-year-olds, 4-year-olds, 5-year-olds, so forth and so on. 18-year-olds, 37-year-olds, whatever it might be. The idea of chronological age in relationship to intelligence testing is that each age group would develop an average. So there would be an average for 6-year-olds. There would be an average for 7-year-olds. Those averages could be used to calculate someone's mental age. So if all of the 7-year-olds scored a certain average on an intelligence test, that could be considered to be the mental age for 7-year-olds. And so if a 6-year-old scored at the 7-year-old average, you would say that that child was above average in intelligence. So anyway, using those basic measures, Binet was helping to develop some kind of way of comparing one individual to the general population according to their intelligence. So those contributions were important for later development. Our next big contributor here would be Charles Spearman. And Spearman was noted for looking at the various test scores that were the results of Binet's tests, and particularly doing some factor analysis in looking at the subtests. So there would be one test, but it would have many subtests. The subtests would try to look at different aspects of intelligence, so verbal reasoning, mental, calculations, mathematical calculations, so forth and so on. And what Spearman did is he found that if someone did well in one subtest, they tended to also do well. It correlated well with their scores on the other subtests. And he identified this as some kind of global factor, what he called the G-score, or general intelligence. And so he consolidates intelligence down into kind of one factor. And this one factor approach is a specific contribution of Spearman. What's going to happen after Spearman is that there's going to be a desire to kind of understand the more nuanced aspects of intelligence and intelligence testing. But G-score and factor analysis are the key contributions of Spearman. This person, William Stern, he is going to help develop the first simple mathematical calculation or ratio that we can use to identify an individual's IQ. What he did was he factored the intelligence quotient of an individual to be their mental age, as discussed by Binet, divided by their chronological age. And then you would multiply that times 100. So if a child had an IQ of 8, and that was if a child had an age of 8, and they performed at a 10-year-old level, we would say that their mental age was of a 10-year-old, but you would need to divide that by their chronological age of 8, and when you multiply that times 100, you get an IQ of 125. Now 125 is well above the average of 100. So that would be an individual who was, identified as being well above average for the normal person. And that's what Stern's IQ allowed us to do, was to take someone's results from an IQ test and actually use it to compare them to the rest of the general population. Lewis Terman was a professor at Stanford University, and as he starts to use Binet's test for American children, he finds it not quite adequate, and so he ends up spending a significant amount of time kind of rewriting the Binet test for an American audience. And so what develops becomes known as the Stanford Binet test. And this becomes the most popular test for IQ in the United States for the next 30, 40, even into 50 years later. And Terman sees IQ as incredibly important and worth being used as a tool to measure intelligence, and he really pushes the use of IQ in American society. He has a famous study known as the Terman's Termites study, which was a longitudinal study of geniuses. So interesting contrast, right, to Binet, who we said was first really focusing on identifying students who are significantly below average in intelligence. Terman's really interested in those that are significantly above average in intelligence. And by doing a longitudinal study is where you look at the same subjects, the same participants for a very long period of time, perhaps as long as their entire life. And for Terman, he's really interested in what are the long-term consequences and impacts of being a genius, or at least scoring very, very high on an IQ test. What Terman learns is that, contrary to popular belief, geniuses tend to be just as well socially adapted as non-geniuses. I think there's this stereotype that the genius cannot really get along in society, cannot really identify with anyone in society, and as a result really struggles socially. Terman finds that not to be the case, that they are, they have equal difficulty in navigating social situations. That they are not necessarily any better, but they're not any worse as well. He also finds that this idea that of the sort of lonely, sad genius is not true either. That he finds that once again geniuses report just as much satisfaction with their lives as the average person. So again, not necessarily more, but not less. Although they did tend to earn slightly higher salaries than the general population. The use of the test as a research method in psychology is an important one, and one of the things that really comes out of all of these early inquiries into intelligence testing and IQ in general are some basic principles about test construction. First of all, in terms of testing as a research method in psychology, we usually divide into two categories, and you'll see that on the slide here. The first category would be intellectual or academic types of tests, and those can be further divided into two different types. Aptitude tests, which measure someone's ability to learn in the future, to solve problems in the future, and so those would really be IQ tests. Vocational tests. You may have taken a test at one point that was supposed to tell you which occupations you might enjoy or be good at. Those are predictive tests. Those are looking at the future, what is likely to happen, not what you already have learned. The second type of test is really that achievement test, and these are going to be the tests that you've taken in school. This is supposed to test what someone has already learned. So if you attend class for a period of time and then you're tested on that material in class, the test is supposed to show you what have you learned from all that information that you were exposed to. The driving test is supposed to prove that you have learned how to drive. The second type of test, or categories of tests, are personality tests. We talked about these a little bit earlier in the year. Personality tests also take two different types. The objective type, which is a simple paper and pencil, usually multiple choice measure of someone's conscious reactions to test questions. There can be some tests that look at just one single personality trait and others that are more comprehensive. One of the more popular objective personality tests is the MMPI, the Minnesota Multiphasic Personality Inventory, which is a popular one that's still used today. The other type of personality test are projective personality tests, and these, as we learned from our look at the psychoanalytic approach to psychology, measure unconscious thoughts and aspects of our personality. So these would be the things that we did in class, like the word association test and the Rorschach inkblot test, and some other ones like the thematic apperception test or the TAT test. Some other ones that we haven't talked about in as much depth. For a test to be considered sort of a good test, or really what we would say is a highly useful test, or a test that has a high degree of accuracy, is first and foremost the test has to be standardized, which means the test has to be administered to usually what's referred to as a norm group. And what that is really it's just a very large sample, as wide and diverse a sample as possible. And the test is simply administered. It's almost like just administering it to the general population and then collecting the results. And if the norm group is a good representative sample of the entire population, then the test should be standardized. It almost doesn't even matter what people's results are. If it's a broad enough sample size, if the norm group is broad enough, then it should result in standardized scores. And that way, any future individuals that take that test, can now be compared to the results because the test has been standardized. And that's kind of what we mean by a standardized test when we talk about it. Now, what we have found is that for most attributes in the human population, a normal distribution works out, or the normal curve, sometimes referred to as the bell curve, which you can see in this graph here below. This is actually a bell curve of scores on the Wechsler Adult Intelligence Scale, the WAIS intelligence test, which is one of the more popular ones still utilized today as well. For the normal curve, what's most important to recognize, of course, is that it's symmetrical, so that the mode, the median, and the mean are all exactly the same. Intelligence tests are usually operate on a scale of 100, where 100 is the average score. So more people are going to score 100 on an intelligence test than any other score. And what happens is there's an equal number of people above 100 as there are below 100. What this graph is showing us is that the standard deviation for intelligence in the human population is 15 points. And so that you'll see between the scores 85 and 115, 68% of the population is going to fit into that category. So it's highly likely that almost all of us fit into that category. And you can see within the second standard deviation, that gets us down to 70 points and 130 points. That's going to be 95% of the population. So that's almost for sure where all of us lie in terms of our intelligence scores. There's a chance, of course, that a few of us could be above that or below that, but the likelihood is that most of us fit into the 95% of Americans. The final key qualities of a good test, along with standardization and fitting according to a normal distribution, would be reliability, which is a quality that says that there are consistent results for the same person on different versions of the test. That's really important, and what we find is that intelligence tests are highly reliable. that people's intelligence tend to work out very, very closely over the span of time once an individual reaches maturity. So if you're scoring at, say, 105 today on an intelligence test, excuse me, you're probably going to get 105 5 years, 10 years from now, 20 years from now, 30 years from now, 40 years from now. And that speaks to the reliability of intelligence scores. It could change a little bit, but it shouldn't change significantly. You shouldn't suddenly go up to, say, 130 or down to 85 if you've been scoring at 105 before that. Now, validity is trickier. Validity is trying to say that the test actually measures what it is intended to measure. That's highly controversial. So is an intelligence test actually saying how intelligent a person is? It may or may not. It may be saying how well a person scores an intelligence test that includes these particular subtests. And it may not accurately measure other elements of intelligence that the test isn't designed to measure. So validity is a little more tricky. An achievement test, like the quiz that you'll have on intelligence, if you get a 90 on that test, then a valid test would say that you've learned 90% of the key information on intelligence. If you can get a 90 on that test without knowing 90% of the information, then that's not a very valid test. And unfortunately, it can be difficult to really create good, valid tests all the time. So there's probably a likelihood that some of your tests haven't been perfectly valid. Content validity is speaking to that standard that I just mentioned, that really the content of the test is valid to the score and the scoring on the test. Is a paper and pencil driving test really going to be valid for knowing that someone is going to be a good, safe driver? It may prove that they know the rules of driving, but you really do need that road test to have content validity for a safe and accurate driver. And then predictive validity, this is a little more tricky. This is for aptitude tests. So sometimes this is known as criterion-related validity. These tests, if a test has predictive validity, we're going to say that it can tell us something about someone's performance in the future. And again, that can be a very difficult standard to assess for. But if a test does have validity, reliability, and it has been standardized with a norm group, it would generally pass as being a test of good quality and one that would be useful in psychological studies and to compare an individual versus the larger population. So these are some of the sort of key characteristics of testing that you should definitely make sure that you're aware of. You can certainly email me questions that you have after watching this and looking over your class notes for understanding the qualities of a good test.